going? He's going to speak around.
Okay. Already introduced us. My name is Neil Kadiachi. I'm the head of the engineering bus division in MA in South Africa. Livingston, over to you.
My name is Livingston Murauzi. I'm the head of product management within MA in South Africa.
Yes. So, a very proud moment for basically our complete organization. Right? We are really excited to share this exciting new product with all of you, and especially our partner Golden Arrow. Like Barbara has mentioned earlier on, we had the opportunity to take a product or components which already has been validated in the, let's call it MAN network of our organization, and sort of convert that into a product that is really what our South African market is really looking for. I'll hand over to Livingston maybe to talk a little bit about the product portfolio of our high floor buses and its application in South Africa before we run through maybe some of the technical details.
We've got a number of products that are high flow. They come from our ICE products, which are diesel powered vehicles. We've got HB2, which is what Golden Arrows are operating, and hence this forms the basis of what they currently have. So the electric bus that we are seeing here is also a continuation of what they have. We also have long articulated buses, HB4 with a trailer. We also have HB4 with operated solo. Those are high capacity commuter buses. So MAN also makes a large bus called a bi-articulated in the portfolio. So the portfolio is really full scope of commuter vehicles. We also have buses that are suitable for BRT applications and city bus applications. So really we do have a full product portfolio that any customer can benefit from.
Okay, good. So to come back to this product, how we came about it. I mean, it was very simple, right? Around 18 months ago, we had a meeting with our partners Golden Arrow, and there was just a simple directive from Gideon. We want our HB2, but we want it in electric, right? So, which was posing a big challenge for us, because today in our electric vehicles, through most of the OEMs, but in most cases the batteries are on the roof, the cooling system is completely on the roof. For South Africa, we have very strict road regulations in terms of axle weights, and as opposed to our European, let's call it regulations, and this posed a big problem for us. The question was, how do we make this into a high flow electric vehicle without compromising our regulations and without compromising the safety of our passengers with regard to rollover simulation, etc. So our team, in a hybrid working engineering environment together with colleagues in Munich, colleagues in Ankara, we brought a chassis and we dismantled it completely, and we said, let us reconfigure it to the application that we need, that suits our industry. Yeah? And from a starting point of view, we took everything that we have normally in our European electric bus products, we took it out from the roof and we put it basically in the base of our vehicle. Yeah? Maybe if I start in the front of the vehicle, underneath, which is traditionally our grille, which we call it in our front engine buses. This is normally where our airflow is, our front engine, our radiator, our cooling packs, and we basically brought the whole cooling system, right, from for our electric batteries, right, the 320 kilowatt battery system, we brought it here to the front. Very traditional, very user-friendly for our operators. They understand it normally in our front engine products.
So in this side we are showing off the layout of the batteries. As mentioned in the presentations, we are benefiting from the Triton Group. These are in-house lithium-ion batteries. In this vehicle we got a configuration of 4 times 80 kilowatt hours, giving us the energy content of 320 in total. So these batteries, they are quite robust. The casing is self-supporting, also with the crash stability in it built in. So unique here, it's as mentioned, we position the batteries within the wheelbase and quite low. This gives us lower COG of the bus, which then translates into better driving dynamics. The energy content, the usable energy is 80%. That is the depth of battery discharge, giving us 256 kilowatts hour usable energy. That is able to give us a driving range from a minimum of 240 kilometers up to 350 kilometers, depending on the driver behavior, traffic conditions. Traffic conditions affect this because then the electric engine should be able to provide regenerative braking, which then charges back the batteries, and therefore we get longer driving range. In terms of the lifespan of this battery set, we estimate roughly 14 years. Also, it all depends on proper maintenance of the batteries that it should be followed. And 14 years for a bus in South Africa is part of a good average lifespan. And even then, at the end of life, the battery holding capacity will still be at 70%. So this is very good system indeed. Naren?
Okay. So before we move further to the rear of the vehicle, just one more thing to add on in terms of the battery. The cooling system that we've, let's say, presented in the front is the complete management of the battery cooling system. You will notice that we have a lot of probes still located on the vehicle. We are in test at the moment. Like Barbara's also mentioned, is that we are testing in our application. We're not just taking a product from an overseas market and saying it will automatically run here. This will allow us to fine-tune the vehicle for better consumption in terms of kilowatt hour per kilometer. And we have a total of 160 probes all over this vehicle. We will show it as we go along. But the complete cooling system of the battery is separated from the rest of its components. This would normally sit on the top of the roof. And our goal was to bring our center of gravity down, give us a lower center of gravity, improve our rollover protection for our most important, let's say, cargo, which is the passengers. In our European vehicles, normally most of these components sit more towards the rear of the vehicle, but we re-engineered them, we brought them closer towards the rear axle. We have tight restrictions on rear axle weights, and this is something that we are also very proud of, to be able to do an electric vehicle to carry the same seating capacity as desired in a normal diesel engine and still maintain the regulations of our axle load requirements in the country was a big milestone for us, and this we are really proud of. We also looked at the opportunity of safeguarding our customers. Rear accident smashes, etc., will have a big impact on our component in terms of cost, in terms of, let's say, downtimes, etc. And was the reason why we tried to bring it out of the danger zones in the rear end of the vehicle, so that we actually also benefit from the longevity of, let's call it, rear accident damages, etc. Our E-engine, it's combined with a mechanical drive axle. So we don't have the E-axle as in most products that we're using. It still maintains the mechanical drive system as you would traditionally find in even a diesel engine, but the engine is just being replaced by an electric motor. Again, like I mentioned, we are still in testing phase at this point in time. You can see we have numerous probes all over the vehicle, and we will continue our testing applications. If we go maybe further.
Yeah, just to clarify, the probes, the green wires, as you see all over,
Yes,
they are not part of the wiring of the vehicle. These are probes for testing. Here we got a charging point for the bus. It's only one unit. It's a standard charging connector, CSS type 2, which is available everywhere where you need to charge, so you can connect almost everywhere. You find a charging point for electric vehicles. So it's not a special connector done for MAN, it's a standardized CSS type 2 connector.
And for this vehicle, with this current battery configuration of 320 kilowatt hour, we are able to recharge completely within less than 3.5 hours at 100 kilowatt hour.
100% charge.
Yes.
Yeah.
3.5 hours.
What's the most range you've got out of this vehicle?
At this point in time, we were, at best, we averaged almost 0.75 kilowatt hour per kilometer. So this gets us well over the 300 kilometer mark. But again, in the next weeks to come, we will test in the operation in the city of Cape Town together with Golden Arrow, and this will give us a little bit better feeling because we can fine-tune the dynamics of the vehicle to the terrain, to the atmospheric conditions, etc. The batteries are also, in terms of cooling technology, managed by all the inverters and the cooling system, best performs between 22 and 25 degrees Celsius, needs to maintain that. And this is why in the system we have both a heating system and a chiller system in the whole cooling line. So it manages itself, so if it gets obviously too cold, our heater system automatically comes in, and if it gets obviously too hot, then the chiller comes in to cool down the vehicle, or the batteries itself. And
So we got
yes.
3 cooling circuits, right? Thermal circuits.
Yes,
Yeah. One dedicated to the battery, and the other one for
the
components.
If you also look at the sorry, Lynn.
Continue.
If you also look at the ground clearance of the vehicle, we have quite high ground clearance, very similar to our HV2 angle of departure to a normal diesel bus that Golden Arrow, for example, today is running is at 10 degrees as opposed to the diesel bus, which is 11 degrees. So we're 1 degree lower there in general. But in the front, we are basically at the same angle of approach. So it gives us also that vehicle type that we need to run in the application. And I think, yeah, maybe lastly, we can all maybe just get into the interior of the vehicle and we can explain a little bit more.
Fire protection.
Yeah.
Yeah, to come to the interior of our vehicle, this is typical a high people mover volume that is operated in most of our operators. Another milestone that we've achieved in all our 12-meter products, the maximum seating capacity we were able to achieve was 65 seated passengers. And in this product, being the first electric bus, we also overachieved, and we also got an additional seat into bus. We managed to get 66. And this was really also another milestone for us because, again, in a 12-meter bus with the front engine, it's normally very difficult to achieve that, but this also gave us the opportunity to do that as well. As you can see, our interior of the bus is very simple, it's very plain, but it's also this is what our market is demanding, this is what our market is requiring. Right? It gives us that airy feeling of comfort even as you enter the bus, and in general, this is basically another step up from our standard HP2, which we do today. And yeah, I think that's to summarize it. I think there's an opportunity for a short test drive.
Yeah.
I think, Tuna, you know the route.
Yeah, I think I can also emphasize the material finish, highly durable, as you can see. As mentioned by my colleague here, this is a high people mover bus, so therefore there's a lot of people in and out, and therefore the seating, the flooring, all has to be made from durable materials. Here, what we also achieve is to use wooden flooring. You don't see that it's wood because it's protected, but that all helped us to achieve the lightweight so that we can get high passenger carrying capacity, or to maintain this electric bus same as the diesel in terms of the carrying capacity. Yeah.
Hello, how are you doing?
I'm well, how are you?
Nice to see you.
Oh, thank you. Yeah, but this you can enjoy as well. Yeah, but you should experience. I have plenty of opportunities.
You're paying for lunch, so you get to say.
Okay, thank you very much. Thank you very much.
Okay.
No, you explain. You start with
Thank you. You stay, right?
We're going to go with the trade flags and these at the bus.
Welcome aboard. Thank you very much. I'm taking you to Joburg. You're going to have to stop and recharge it. Anybody brought water?
Principle of the business.
The same image, the same everything. No, that is just the vans. Because that's also another question. You hear much more the noise that you would have never heard before. Else you heard the engine. You have to have something to say, of course. No, then the noise what you need like the zoomer. I think when it comes below 35, it got to make this zooming noise. Because else the tires actually making the majority of this.
And we were playing, all of us as coaches, we had such a nice time. Really, I will this next time together.
During the day I was always in I'm also
How long is the charge time? And if you operate at 85% charge or 100, you need to go to 100. And how will you charge it? Will you use solar energy or will you plug it into the grid? Is the capacity the same as the standard diesel bus? In other words, do you lose passengers because of the heavy load of the batteries? And then also just, if I may, Jan, one last question, local content. What is the local content on the diesel bus versus the battery bus do you anticipate? Thank you.
I think you try to remember all the 4 questions. You were saying 2, and I think I've gathered about 4. We'll start with the charging time.
It's real engineering news.
Okay. Okay, it's working. So, in terms of the charging time on the 320 kilowatt system that we're operating at the moment, we obviously discharge to 80% DOD, and we're able to recharge back to 100% at 100 kilowatt hour over 3 hours, just under 3.25 hours.
DC charge?
Yes, DC charge.
Okay, so I don't think it's a secret Bolsonaro wants to buy 60 electric buses, at least 60 electric buses every year. You've seen the graph that was shown about our peak profile. So in the middle of the night, all our buses are standing still. We hope to charge it with off-peak ESCOM electricity at that point of time, to start off with. In the middle of the day, we will use whatever solar we have, and we've been going ahead with quite a large solar project. All our depots have got some solar in it at the moment, but we are investigating wheeling arrangements from solar plants and wind plants up north. We are looking at every possible opportunity to use green energy, but for the start, it will probably be ESCOM and solar mix for us right now. Gideon, do I cover that? Okay. Was there anything else for us? I don't think so.
The next question was to the passenger capacity.
Yeah, the Passenger capacity is 66 passengers seated, which is 1 passenger more than the equivalent diesel bus.
And then the last one was on the local content. It's difficult in the project stage actually to answer that question, since obviously at the moment we haven't done the assembly of the chassis locally yet. So at the moment this chassis has been come in as 100% CBU. So the local content on the CIB of the assembly has to be added to that, and also on the bus body. In terms of percentage, simply due to the higher cost of the bus chassis, with the higher cost of the batteries compared to batteries in the electric drive compared to an ICE version, the local content actually on the electric bus will go down. That is just the facts put together. So whereas at the moment we're looking, I haven't done the maths so far. So at the moment we're looking at about 45% local content versus 55% on the chassis, approximately. And on the electric one, we will still have to do the maths. Can't answer the question at the moment.
Thank you. Thank you.
Thanks, Greg from Roadhead Magazine. Was there any idea to put solar panels embedded into the roof, number one? And number two, there are some fire concerns around lithium batteries. How did you take that into account designing the bus? And third, what sort of cost savings are you noticing per tank, electric over diesel, or is that too early for you to go to those numbers? And also last one, if there's time, how much extra weight is on this bus compared to the diesel?
From the roof of the solar panels, they can answer. We have running development searching projects for that. But at the moment, the energy that's coming from there can be a supplementary of the climatization of a vehicle in the European applications. That's why, although the energy and the application research activities are ongoing, we are not in the state of the technique at the moment that the whole bus will be able to drive from this energy resource on the roof of the vehicle. We are not there yet.
Maybe I can just add to that. Buses carrying capacity is determined by the axle weight, or the weight of the axle on the top. So the more weight you add with solar panels, the less passengers you can carry. And a bus doesn't operate so many kilometers. A bus goes out in the morning, it does less than 200 kilometers, it comes back, it stands for 5 hours, and then it goes out in the afternoon again. So you actually don't need it. With Gideon teaching me, he told me that even if you have solar panels on the roof of a bus, it is too few solar panels to really make a proper charge on the bus. It will hardly even maintain it. So we have ample time to actually charge it. Can't remember what the rest of your question.
And cost saving electric versus diesel at the pump?
Okay, so I don't think it's a secret. Gideon has mentioned it on many presentations. We will save 70% of our operational cost. But that does not take into consideration the purchase price of a bus, which is much more. So over lifetime, there's definitely a saving for us, but it's not close to the 70%. Obviously, it's far less.
So in terms of the weight in comparison to a diesel bus, so we're roughly about 1.8 tons heavier. However, with our, let's call it creative engineering on our body skeleton, the low center of gravity that aids us with the battery positioning allows us to go even a little bit lighter on our body skeleton. This is how we still manage to maintain, actually get one additional seated passenger into the bus as opposed to a normal diesel bus.
And the final one, in terms of dealing with lithium-ion batteries and the flammability, do you firewalls beefed up, that kind of thing?
Okay. Okay. So, in terms of the batteries, so we just touched on the technology of our batteries, but within the complete Trayton group, and as Barbara's mentioned, with us sharing the technology, our batteries is crash protected already. Even though we've added an additional crash protection on the side of our vehicles, we've also done burn tests on the batteries as well. So in terms of insulation, we've got the batteries in terms of gases is able to be exhaust in the bottom of the vehicle, so no harm comes to passengers. And in terms of with regard to fire protection, we've obviously encapsulated our batteries at the bottom in the wheelbase. Post our testing activities, there's further engineering, let's call it, additives that we will add on to, let's call it, safeguard that from that point of view.
Maybe I can.
Yes.
I try to touch this topic very briefly. There is a very standardized MAN safety house in our development roadmap, and all of our products, not only in the diesel but also in the electromobility. And we also add some additional feature to MAN safe house, how we need to test. And as I said, from Spain to Norway, I am underlining, especially for these two countries, in order to show you the temperature difference in between countries. So we have more than 5 million kilometers, not only in the engineering testing, but in the hands of customers. So we are fully trusting our battery safety and our vehicle safety at the moment.
Good day to everybody. I'm Professor Viability. Just from a technical point of view, your batteries are obviously outsourced from different companies. Let's say these booms, other bus lines get into it, like your Northwest Star and other provinces get into the problem of buying electrical buses. From a main perspective, are you going to be basically making your factories bigger? Are we going to be looking at these batteries being manufactured here? Because if you look at the core of the lithium power plant, it's basically Zimbabwe graphite is also needed into elements of building this battery. Are we looking at these batteries being manufactured in South Africa, or are we just going to continue getting them from outside?
Yeah, I think that's a very good question, and a geopolitical question and geo-economical question. So my answer will not be very precise. But yes, we also recognize that Southern Africa and the surrounding countries actually have all the ingredients available, so to say, what's in the ground to actually make batteries. And actually the game, what we see now when we're going into step by step into battery manufacturing, is that we have to secure also the sourcing, so to say. And from that perspective, we as a member of Volkswagen Group, we also take part of that, and we have a joint cooperation with Volkswagen Group, where we source in Africa, where we source also go in Canada, but also in source and also produce in Sweden. So we have a different setup. Also throughout the coming decade, we will also shift, so to say, and have different cell manufacturers, but what is very important is that the cell chemistry and the cell setup, and also the module to pack setup, that's a complete unique MAN, and I would say also a unique Trayton design, which is dedicated for heavy-duty vehicles, as that is detrimental to differentiate from the lifetime of a commercial vehicle, a bus or a truck, versus actually a pass car. So this is the start, and we're really happy that with Golden Arrow we made this start, but you can bet that in the coming decades to come there will be quite some steps into battery systems when it comes to cell chemistry, when it comes to packing, when it comes to energy density, so energy to kilo, energy to 2 liters, and also when it comes to the recyclability and a recycled part of the battery system. So also here, sustainable perspectives are taken along there, and that also should include, to our firm belief of our corporate purpose, of course also that the sourcing of the material is sustainable here and now and going forward.
Good afternoon, it's Tristan from Business Fleet Africa. I just wanted to ask, with this specific unit outside, how did the spec of the vehicle have to adapt to a certain route? Because obviously, typography can affect the range and things like that. So did you have a certain route in mind, and is it going to only operate on that specific route?
No, not at all. These buses can operate on any route. It's more the distance thing, and distance is not a problem because, like I've already said, bus hardly do more than 200 kilometers. It's not route specific at all. It can go up any hill. We've tested it, and we'll be testing it with sandbags before we load passengers in it. That's how we've done the 100,000 kilometers we've done. There is not a hill in Cape Town where it cannot go up. There was this rumor going around that a MyCity electric bus didn't go up. Those buses cannot go up any hill, there's no problem with it. So any route, anywhere in the Western Cape, in our operation, Golden Arrow's operation, not a problem.
From my own experience, as I've been cruising recently our truck as well, basically we do full recuperation. So you can recuperate close to 1% of the engine power when you actually cruise down the hill. From that perspective, it's sustainable also from the brake linings. And it's also good that you actually can use also the gravity force going downhill accordingly, and that you can recuperate to a big extent.
Hi guys, Steven Spulu here from Daily Sun. I'm gonna go back to batteries again. I just want to know, was a thorough assessment done in terms of the risk assessment to safeguard the batteries, as we know that these batteries happen to be the hearts of these buses. As we know that mobile, let's say, network towers are being targeted for battery theft and stuff like that as a result of load shedding and other power struggles. So I just want to know which measures are being put to safeguard these batteries. Secondly, I just wanted to know about the partnership with Galdoneros. Is it solely their presentation to you guys, or are you open for more partners in the future? Or can I just come and say, hey man, make a bus for me? Thank you.
I would love to see that. I'm full-hearted these things, right? So come over, we'll negotiate. And maybe I'll start with the last one. As explained early on, we want to go into a field test, and we're partnering up with Golden Arrow based on our long existing partnership for that field test. However, this technology, this vehicle is not just a vehicle for Golden Arrow. It's called the Lions Explorer E. It's not called the MAN Golden Arrow type. Right? It's a vehicle which we intend to bring to more partners in South Africa, possibly even outside South Africa. And yes, we have other operators in the country who have shown interest in this vehicle as well, and we're more than open to that. However, let's do the test phase first, and then we'll go and partner with others as well.
Recycling batteries no, risk of theft.
I was asking about the risk of theft with regards to batteries, yes.
So maybe I can answer it in two parts. I think the first part, I think you would need to be really creative to remove one of those battery packs. I mean, it's close to 600 kilograms. And given our configuration on how we, let's call it, placed it into the vehicle, like I said, you need to be very creative. Secondly, as we've also mentioned, we have a crash protection on the side. So as it is still in the test phase, we've made it obviously easy to remove the crash protection at this point in time, which we've already done simulation work in our simulation house in Munich. But this will also be somewhat as a safeguard removal system. So not anybody can be able to remove it. I mean, we will have that obviously for our operators, for our server centers, to have the access to remove it, but not just for the general public, I mean, from a safety point of view.
Also, there's no system that is 100% safe. We see today with the ICE products, theft of diesel is quite a big thing, and we do have devices, but people still get a way around it. But as my colleague said, you'll have to be very creative to steal those batteries.
And brave.
And brave. We're talking of, yeah, the bravery part is important because we're talking of a high voltage system.
Sure. In Europe, as we all know, government subsidies have played a huge role. What is the latest in South Africa? Are you making progress when it comes to chatting to government and getting some subsidies? And Francois, is it actually viable to run electric buses in South Africa without those subsidies if you don't get them?
So there's absolutely no progress with subsidy for electric, for going green, for bus companies on contract with government at this point of time. For us, it is a commercial decision, and over a lifetime, I said we save 70% of the operational cost. But over a lifetime cost, including the capital of the bus, it's better than breaking even. So therefore, it's good enough for us to go green in any case. It's definitely better than a diesel bus over the same lifetime. And if we now heard that the batteries can last 14 years, we were doing our sums on 9 years. And what I can also say is all our sums were incredibly conservatively done, on the highest electricity rates, on the shortest charging times, with load shedding involved. We worked as conservatively as possible, and still it is better than a diesel bus over a lifetime. By how much I cannot tell you at this stage. That's what we're going to test it for.
And as this takes off, would you be looking at old diesel trucks that are coming end of life to be refurbished into electric trucks? Is there an option for that, or is this ground up stuff? Buses. Buses, yes.
We have seen in Europe some conversions being done in this regard, but I personally don't believe that this is going to be a viable business here for South Africa. Simply since it's not exactly the same chassis, so it's not just taking out of the components all and putting in. I had a discussion early on with Francois when we said, you know, we were just saying there is the HP2, just remove all the diesel and put the electric in and it's done. It's not that easy, it requires more. Also a bus body has a certain lifetime expectation, and if you run into, we heard today they're operating in 18 years, if you run into 6 years of operation and then have only 12 years left, whereas your battery power operation could go for 14 years, then this does not match any longer. So I don't think that is going to be the way forward.
Gideon should really have been standing up here. Gideon's been working with the University of Stellenbosch to convert one of our old MAN buses to an electric bus. If you ask our financial director, Mr. Mark Wilken, he will tell you it's not going to be viable, and that's exactly what Jan is saying. But we're doing it almost just to tick that box, because we sit with 1,000 diesel units that's still going to last us for many, many years. So if it was viable, it becomes an option. But at this stage, it really doesn't look viable. But we are doing it with the university just to see what does it look like, what does the figures come to. Yeah.
Okay. Anyone else?
If there are no more questions, then I would like to thank all of you helping us answering those questions. Thanks for your questions. We've prepared some food for you outside, and then obviously we're still here to engage. Thank you very much again for coming. Thanks for joining us in this memorable moment. I think in the partnership with Golden Arrow we have a great future ahead of us by electrifying Africa. Thank you so much.